Okay, Andrew Schwartz, finally, from the University of Pennsylvania. He got a PhD. He's a leading research scientist for the World Well-Being Project and postdoctoral fellow in computer and information science and the Positive Psychology Center at the University of Pennsylvania. He focuses on large and scalable language analysis for health and social sciences, utilizing natural language processing and machine learning techniques. He has discovered behavioral and psychological factors of health and well-being as a manifest through language in social media. He received his PhD in computer science from the University of Central Florida in 2011 with research focused on acquiring lexical semantic knowledge from the web. His recent work has been featured in Wired, Scientific American, and the Atlantic Cities. Starting this fall, he will be assistant professor at Stony Brook University, State University of New York, right? Okay. So please, Andrew, thank you.
Thank you for the introduction, and thank you to ANEHI, Infotech, and CIDE for the invitation to talk today in this wonderful event. So I'm going to be talking about a project we've been doing at the University of Pennsylvania, the World Wellbeing Project, in which we try to take information from social media and use it to, one of the aspects of the project at least, is use it to inform policymakers. And this is a large collaborative project. I guess we call it a big collaboration. With some key people, Martin Seligman, who founded the Positive Psychology Center, Johannes Eichstadt, a PhD student who's here today as well, Lyle Ungar from computer science, and Peggy Kern and Greg Park, postdocs in psychology. And we have a lot of people from many different fields all coming together to try to utilize big data to better understand people and to potentially replace in part, surveys, typically costly surveys. And so, don't need to say too much about social media to this audience. When I mention social media in this talk, I'm referring mostly to Twitter and Facebook, but there's lots of other social media coming out nowadays, and in general, the trend has been increasing in the number of people who are on social media. Yeah, this being I probably don't need to say much more here since this is the International Conference of Datus Grande. So, but I do want to point out that for our research, the key is that not just that it's data points, not just that it's a lot of messages, but that it's people. So Twitter is now up to at least 150 million monthly active users. Facebook is up to 1 billion, 1/7 of the world population, at least they claim, is actively monthly using Facebook. And so why do we care about language and social media as a type of variable to study? Well, one thing is it gives us an unprecedented sample size. Psychological studies are often limited to hundreds, if not even tens of people, and this gives us the ability to get, well, potentially to billions. Today we'll be talking about around hundreds of thousands of people. Also, we have a lot of data per person. Many people are daily sharing lots of their everyday thoughts and feelings, and these data are self-descriptive. Language in some ways speaks for itself. When you see a word being used like happy, it's not perfect, but for the most part, you get a general sense of what it means that happy is being said more on certain days. As I mentioned a second ago, also covers just everyday concerns, not necessarily prompted information, which is really important for bringing these types of methods to use data-driven science, exploratory analyses, not just hypothesis-driven analyses. So the idea is we can discover information that we never intended because we're not necessarily prompting people with certain variables that we're looking for. We're just looking at whatever anyone chooses to communicate. It's unobtrusive, doesn't take time, as in a survey, to administer and answer questions. It's also longitudinal, allows you to look back in time, even after an event occurred, similar to as Fabian showed. And lastly, there's a potential for real-time analyses, for example, showing the well-being of a population over time. That would be very difficult with survey data to do on a daily basis. That would be a lot of surveys, especially if you wanted that geographically located. However, natural language data in its raw digital form that we often get it in, a string of characters, is not very statistically meaningful. There needs to be some processing there, and that's where my background in the field of computational linguistics comes into play, where we normally try to better model and understand language, get computers to better understand the meaning behind the language. But then in psychology, it's not so much about understanding the meaning of language, it's more about understanding people. And so our project kind of brings these two areas together, and we're kind of going from modeling language to better understanding people. And so in computational linguistics, the goal is often accurate prediction, and the methods have been data-driven for quite some time now. Most of the modern methods would probably qualify as big data, depending on your definition of big data. However, in psychology, the goal is human insights, better understanding people. But typically, the methods being used for language analyses are what you might call small data. So we bring these two fields together, and we create data-driven insights and measurement. And everything I'm going to talk about today will fall into these two categories. I guess the pointer doesn't show up, of insights or measurement. And I want to emphasize both points. I think measurement is typically what government is interested in, but a nice thing about big data, which policymakers, I believe, should also care about, is this idea of insights or finding connections with the data that you never anticipated. And so, as an example of that, we took 75,000 users from Facebook who signed up for an application called My Personality. This is with collaborators from Cambridge University. There's a total of 20 million statuses, and these users took a personality survey. And then we just looked at what words correlate with different types of personality. Here's extroversion. Extroversion is the type of person that's very outgoing, somebody who's energized by socializing with people. And so we see very obvious results. Party, love you, baby, girls, there's boys in there somewhere too. And so this is interesting. This result is pretty face valid, we like to say. Kind of gives us what we expect, although there might be things we probably couldn't have come up with this on our own. But it makes a lot of sense. And then we look at introversion, which is one of my favorites, being a computer scientist. And we get stereotypical interests, I think, that you might expect from an introvert or computer scientist, such as computer, internet, Google. But then what we also see is this emergence of anime. These symbols here are actually Japanese emoticons, and lots of interest in Japanese culture, which in retrospect does make sense, but it's something that had never been studied about introverts before. So this kind of demonstrates how this insight piece can introduce new pieces of information we hadn't anticipated, and in a sense generate hypotheses. As one more variable, I just want to warn you, there's swear words in these results. It's all data-driven, nothing censored. We actually call it an open vocabulary approach, so if you're offended by such language, look away. So this is the people who are high in neuroticism, or words that correlate highly with neuroticism. I didn't mention it before, but the size of the word is how predictive it is of the outcome. So neuroticism is characterized actually as being depressive, anxious, a little emotionally unstable, and a lot of scientists that tend to fall into this category. um, we see here, yeah, again, very straightforward results. The size of the word, as I was saying, is how predictive it is or how much it correlates with the outcome. The color is how frequent it is. So we have a word like depression is not very frequent, but when it does occur, it's quite predictive of being neurotic. And then on the other side is what psychologists call emotionally stable, the other end of the spectrum from neuroticism. And we get things you might expect, beautiful day. But we also see this big interest in sports, including soccer, by the way, or football. This was all English-speaking and predominantly U.S. Participants. So, but we do get, I know we do get some soccer teams in some of the results, like Arsenal and some teams from the UK. I imagine if we ran it in Mexico, though, it would look different. And so, but yeah, this idea that emotionally stable people have this interest in sports is another new kind of insight that we now hope to investigate more specifically in a controlled study, but it's not something going into this our personality psychologists thought would come out. Okay, so that's kind of the introduction. Here's how my talk is going to proceed from here. I'm going to talk a little bit about individual analyses, where I will explain how we produce these results. In this case, it's over a sample of Facebook users that I just mentioned who participated in an app. They consented to sharing their information in order to for this research. And then I'll talk a little bit about community analyses and how these measures can be scaled up to measure well-being across communities, in this case in the United States, but ANEHI, in fact, is even working on similar techniques for Mexico. Again, we have these 2 points of insight and measurement. We'll start with insight. So our method, we try to not have a black box method. And the idea, because we're working so much collaborating with different fields, is we really follow this approach of an Occam's razor, or trying to keep our method as simple as possible to get good results. I need to zoom out here. And so the basic idea is we take somebody's information, it can be broken down into messages and an outcome, and we can extract features from that. What that's essentially doing is taking this unstructured language data that I mentioned, raw data, and turning it into variables that you can run standard statistics on, or large-scale statistics on, or machine learning on. And so we extract n-grams, which is really just a fancy, linguists don't like to use the word. So n-grams refers to, for example, 1 gram is much like a single word. A 2 gram is a 2-word phrase, and 3 gram is a 3-word phrase. And then we also extract these things called topics. Here's an example of some topics. These are groups of semantically related words that are automatically found using an unsupervised approach called latent Dirichlet allocation. It finds words that tend to, similar to factor analysis. Factor analysis has properties that don't work great for language. Latent Dirichlet allocation is a Bayesian model. It doesn't have to be linear relationships, and it produces these nice chunks of language that are a little easier to digest than just looking at all words and phrases. So we extract these 2 types of features. We do a correlation analysis where we correlate them all. In this case, it's like a total of 30,000 different features, but we've got 75,000 different people, and then we see how much they correlate. And we also do very importantly, we correct for the fact that we're observing around 25,000 variables using usually a Bonferroni correction. There's other options out there. And so we only present results that are statistically significant. And they go into a word cloud. I'll save the details of the method. And so here's another example based on gender. And just to warn you, this is how some of the media interpreted our results. Again, we didn't hand create these clouds. This is just what emerged from the data. And so maybe you can guess which cloud is for males and which cloud is for females. So this is the female word cloud. Again, the size of the word is its correlation strength. For example, less than 3, which is a heart emoticon, is actually the most predictive feature of being female. And then around the outside are the topics. So these teal clouds are groups of these semantically related words that kind of let us digest the information in chunks that are a little easier to maintain. And so you get kind of a cute topic, a birthday topic, a boyfriend topic, a love topic. And then if we go to men, I'm a little embarrassed to be a part of this group. We get swear words, we get sports, fighting, government, and yeah, lots of different. One of the nuanced points we found is that for men, my girlfriend and my wife are very predictive, and for women, it's just husband or boyfriend. So males seem to like to use the possessive a little more when saying those words. It actually turned out when we looked into it that women, on average, tend to talk about other people's husbands and boyfriends more, and so. And then we can do the same thing for age groups. We have various groups here. One limitation with Facebook currently is there's not a lot of people over than 30. So we kind of cut off our last age group there for this analysis. We're getting beyond that now at this point. Just as one example, here's the 23 to 29, kind of the group leaving college and going on into the workforce. You can actually see a job hunting topic, a kind of time planning topic, a dinner tonight cooking, kind of, switching to more domestic life, and of course still a beer and drinking topic. For the younger age group, there's actually a hangover topic that comes out, but that goes away at this age. You've learned your lessons, I guess. Okay, so then on the measurement side, the idea is we can do the same type of analyses, but when we fit our model, instead of running correlation, we can use machine learning and try to predict the outcome. The difference here, I don't want to go into too many details, is we're basically doing a multivariate fit rather than a series of univariate fits. And we want to do a lot of controlling for covariance so we use penalized regression, in this case, ridge regression. And so if we try to predict people's personality from their language, we do, in general, as well as friends. So language is the green bar, friends are the blue bar. In the case of openness, we do better. For some reason, that's really easy for language, more difficult for friends. But in general, we can predict people's personalities, just roughly how their friends predict their personalities. We can also predict age, roughly within 3 years of your age, and 92% accuracy predicting what your gender is, just based on your language. And so taking these analyses and moving on to the community level, we analyzed tweets from Twitter and tried to measure well-being. In particular, we use the life satisfaction scale of well-being for the work I'm presenting today. We're also doing work, though, using more of a dashboard approach where they define well-being as encompassing many different components, not just being one variable, but a series of variables. I just want to mention that because that's where this work is going. You might ask, why well-being? Well, people care. In the UK, 81% of people care more about greatest happiness than greatest wealth. The OECD now has guidelines out there. Many countries, including Mexico, have initiatives in place to measure the well-being of their population. In the US, the Gallup and this organization and then the CDC, which is part of the government, are measuring life satisfaction. We use the CDC life satisfaction data, And we essentially, what you see here on the left is a map of the CDC data of life satisfaction. Green means higher life satisfaction, red lower. We plug this into our model, and we extract language from counties in the US that at least mention a certain amount of words. We extract their language, just like we do for the individuals, except this time at the county level. And then we plug into it this life satisfaction by county information from the CDC. And so we're able to build a model that predicts life satisfaction at the county level. However, when we do this, we hold out some counties so that we can test the accuracy of our model. And this right here is our predictions of life satisfaction based only on language use from each county. And we find that there's a correlation of 0.535 based on our model from Twitter. So Twitter's able to predict life satisfaction at the county level. We also throw in some controls, we call them, information that typically predicts life satisfaction, such as demographics, ethnicity, or socioeconomics. Places that have more money to a certain extent tend to be happier. And so we want to know, is Twitter contributing anything above and beyond these standard predictors of life satisfaction? And the answer is yes. When we only use the controls, we get a correlation of 0.435. When we use the controls and Twitter, we get 0.535. So then we ask the insight question, well, what is leading to these predictions? And we see, similarly, lots of different topics. You can look this up in our paper. I just want to point out one topic in particular that I like is this money topic. So we talked about socioeconomics correlating with well-being. Well, it turns out we have a lot of socioeconomic related topics, a lot of money related topics, but the one that's most predictive is a donate, charity, kind of philanthropy topic. So this is saying that areas that have people who are talking more about donating are the happiest. It's kind of given insight, into, these links between well-being and economic status and behaviors. And so we did the same thing looking at heart disease mortality. Johannes, my colleague who's here, headed up this work, so if you're interested, you can talk to him a little bit more about it. But the idea was looking at county-level heart disease mortality. We extracted a bunch of different features. In this case, we did a little more advanced machine learning. We had to do some feature selection, apply some dimensionality reduction, and then we fit our model to this county-based heart disease mortality. And again, we held out counties in order to test that our model is accurately fitting the heart disease mortality. It's not just happening to fit whatever we tested on. It's not just what's called overfitting the data. So we tested on new data. And what we found when we look at standard predictors of heart disease, demographic information was somewhat predictive. Those are what those bars you see there are. Then obesity, hypertension, diabetes, and smoking are those next bars. They were even more predictive. When we factor in income and education, we get this prediction. These are correlation values between a model prediction and the real values. And then when we use all of those predictors, so it's taking in standard predictors of heart disease plus demographics, socioeconomic information, we get a correlation of about, 0.3. And then when we only look at Twitter, so in this case we're not using that information plus Twitter, we're just looking at Twitter, we get a stronger prediction from Twitter alone than all of those other variables. So we were quite surprised to see this, and implying essentially that Twitter is capturing much more than these standard predictors, and that's without even putting them into the model. It does a little bit better when we put them into the model as well. And then again, we say, well, what's going on here? What's being predictive? And we see things like higher status occupations, topics that might relate to that. These labels were I don't usually like to label the topics, but the psychologists like to, so I just want to give that quick disclaimer. The psychologists label these topics an anger-related set of topics, a negative relationships type topic, and a disengagement type topic. And before this, it's very hard to study what community attributes, psychological attributes like anger, how do they relate to health? And you'd have to do tons of surveys. And so Twitter really allows us to get that sort of insight. So lastly, I just wanted to point out, good, related to kind of summarize how this relates to public policy. And one of the key points is just related to surveys. Surveys are expensive. If you want to get county level, fine-grained geographic information about people, it's expensive to call millions of people. And so that's actually the second point. And so this provides an inexpensive way to do that. Of course, once you get everything set up and the research is just about there, where I think it's going to be easy for many places to adapt this. The other point is it's unobtrusive. The people in those locations don't have to take time to answer their phones. Nowadays, it's hard to even get good survey responses because people don't have landlines. And at least in the US, there's laws against calling cell phones. And then there's the potential for real-time data. But on the bad side, Twitter, social media are still a little bit biased. However, this can be handled. And one thing I'd like to point out is with our study, that we're not evaluating our models against a biased sample. Twitter may be biased, but we're comparing our language from Twitter to a unbiased sample. So we've got people who take phone surveys, who are in the light blue here. We've got people who tweet, and then lots of other people. So the phone survey people is a non-biased sample. And so we divide them up this way. And so on the left, you've got the tweeters, which is biased. On the right, you've got the survey takers, which is unbiased. We fit our model of potentially biased data to unbiased data. And then when we test it, we're testing against unbiased data. So in this way, you're fitting essentially unbiased data to map into biased data to map into unbiased data, and that's what the accuracy represents, is how well is Twitter predicting unbiased, stratified samples that are provided by the CDC. And then lastly, it's not a total replacement for surveys. You still need surveys to tune these methodologies, maybe to feel more confident with them, but that can be at a much more limited scale. You're not talking about millions of calls, just things to check in and make sure these models are functioning correctly. And so thank you for your time and attention.